Welcome back, everybody, to the Python Primer for Student Researchers. Today we're going to be talking about curve fitting and using scientific Python and Python to fit data with linear and more complicated curves. This is something you might be familiar with from Excel. We do this in our physics lab where we use the program linest to do linear estimations with parameters and their associated uncertainties. We're going to extend that to being able to do that with more complicated functions. But we're going to show you how to use SciPy to do those things. So first of all, let's get started by importing the libraries that we need. So we're going to need from SciPy, we're going to import our stats package. So we say from SciPy import stats. I'm also going to need my typical NumPy and matplotlib so that we can look at the results. So I say import matplotlib.pylab as plt. Okay, so I've got my libraries installed. The first thing I want to do is figure out what sort of function I'm trying to fit to. So this is where you look at your data and say, well, what type of model do I want to use to analyze my data? For most physics applications, or at least a lot of physics applications, you can linearize most data, and you do this in your physics lab. So I'm going to go ahead and define a function that's just aligned as a typical slope times x plus the intercept. So let me go ahead and do that, and I'm going to use this function throughout this activity. So I'm going to start by defining a function. I'm going to call it line, and that's going to take my data from the independent variable. It's going to return a slope, and it's going to use a slope, and it's going to use an intercept. And I put a colon there, and then I'm just going to say return slope times x data plus intercept. And I could have just did mx plus b, but this is a little bit more descriptive and more to my taste. So what I can do is if I pass in an array of x data, it's going to return an associated array of y data. So next thing I'm going to do is I'm going to generate some data for us to play with. And that data, I'm going to introduce some error bars to that so that we have, it's not just a typical line, but it's going to be based on this line. So we're going to use a slope and intercept to generate the data. I'm going to add some uncertainty to the data, and then we're going to see if we can extract the slope and intercept back from that. So let's start by making an array that is just x data. And we're going to say this is just an array, should say linspace. This is just an array of data from 0 to 4, and we're going to put in 10 data points. So this is 10 data points distributed from 0 to 4. And then my y data is going to be equal to the line that's generated from the x data with a slope of 2 and an intercept of 4. Okay, so I'm just making these things up here, but that's just showing me that that's just giving me a line based on this function here. And then I want to add some error bars. So I'm going to say use some error bars. And let's say we're going to make these error bars based on the random number generator that NumPy has. So I'm going to say 2.0 times mp.random, and then I have to give this a size, and the size is going to be my x data array size. So what this is doing here is it's saying generate a list of random numbers between 0 and 1, multiplying by 2, and that's just going to make it so you can see them on this graph, and then put that in my error bars. And then I'm going to add that to the data. So my new y data is going to be my old y data plus my error bars. So now if I plot these, if I do plot x data, I need to do plot plt.plot. If I do my x data and my y data, you're going to see a graph. Whoops, need to spell size correctly. You're going to see a graph that has some associated uncertainty to it. So let's make that into some data points there. So that has some data points that just have some associated uncertainty. If I were to go ahead and execute that before I did my error bars, I would get a perfectly straight line. Okay, so there's some data with some error bars. Now what we'd like to do is go ahead and plot that. Let's go ahead and plot that with the error bars themselves. So I'm going to say plot.plot, and I'm going to put, actually, let's make this just the error bar. I'm going to say x data, y data, y error, and then we're going to make these, format these as circles. Okay, there we go. So there's our linear data, and it's got some errors and uncertainty in it. You can see the larger the error bar, the further it is away. Let's go ahead and put a label in here. We'll call this our data, and we're going to put a x label as, let's call that x unitless, and we'll do our y label y unitless, and then we'll say plot.show, just so we know we're closing off the graph there. And there we go. We've got a nice graph showing us our data. Okay, so now what we want to do is want to fit a line to this. So we're going to do that by using a package called linear regression. So let me just show you how to do that here. I'm going to go ahead and do this right up here so that we can plot the results. So what I'm going to do is I'm going to call this function linear regression, and it's going to return a bunch of values. It's going to return a slope. It's going to return an intercept. It's going to return the R value of the fit. It's going to return the P value of the fit, and it's also going to return the standard error of the fit. Most of these things we're not going to be using, but those are the values that are returned by the stats package. And then I call the stats package. I say stat lin regress, and then I give it x data and y data. And any set of x data and y data you will do this. And I'm going to go ahead and then print the slope and the intercept. And let's see what we get. So I do that, and I get a slope of 1.8 and an intercept of 5.2, which is not 2 and 4 because of the associated uncertainties that we put in with the data and the error bars, but they're in the ballpark. So we're getting the slope and intercept based on these error bars, which are not the slope and intercept that we were originally given. But it did do the fit. The problem is this doesn't actually give us a uncertainties in those values. But let's go ahead and plot them on our graph anyway, so we can see what we have here. Okay, so what we're going to do here is we want to plot this line. So we're going to create an X line, and this is going to be a relatively dense linspace line from 0 to 4 of 100 data points. And then we're going to create a Y line based on that slope and intercept. So I'm going to say line. So again, I'm calling my function line on using my X values from X line and the slope and intercept that I just calculated. So those are the slope and intercept from right there. And then I can go ahead and plot those. So I'm going to say plot.plot, X line, Y line, and I'm going to give it a label. Label equals, this is the linear regression. And there it is. Okay, let's put a legend in here so we know what we're looking at. All right, so there's my data, there's my linear regression. Perfect. Now, what I'd like to do is know what the uncertainties in the parameters are. So I know my slope and intercept, but I don't know what the uncertainties are. And in order to calculate those uncertainties, I can do that two ways. I can do a weighted least squares, which uses these error bars, or if all the error bars were the same, I could use an unweighted least squares. So let's see how we do both of those. So we're going to do that in the next video.